Hello, wonderful people. I welcome you all to Physics with Umoru. We are going to be looking at the topic images formed by a concave mirror. But before we move into this, I would like us to look at the images formed by the plane mirror and the images formed by this mirror known as the convex or the diverging mirror. Okay, whenever an object stands in front of a mirror, you expect to see the image of this object. It is either the image of this object is seen in the mirror or the image of this object is seen outside the mirror. When the image of an object standing in front of a mirror is seen in the mirror, this image is what we call the virtual image. The virtual image can be seen in the mirror, or what we call behind the mirror. While the type of image that cannot be seen in the mirror but seen outside of the mirror, when we place a screen or any whiteboard outside and the image will be formed on this whiteboard, this type of image is what we call the real image. Okay, so I want us to first of all look at the images formed by the plane mirror. This is the most common mirror we have in our various homes. This is called the plane mirror because the face is plane. What are the properties of images formed by the plane mirror? Number one is that the image is virtual because when you look at yourself with this mirror, you are going to see yourself right in the mirror. So the image is virtual. Number two is that the image is upright or erect, which means that the image is not turned upside down. Because there are some mirrors that when you view yourself in this mirror, you will see your image turned upside down. So this type of mirror will produce an erect image. If this marker is placed this way in front of the mirror, this is exactly what you are going to see in the mirror. Another property of the image formed by a plane mirror is that the size of the image is the same as the size of the object. It's not going to enlarge it. It's not going to reduce the size. The size of the image is always the same as the size of the object standing in front of the mirror. Another one is that the image distance from the mirror is the same as the object distance from the mirror. For example, if you are standing 2 meters from a mirror, your image right in the mirror is going to move 2 meters. Exact distance the object is from the mirror will be the same distance the image will make from the mirror. And the last one is that this image is always laterally inverted. The image is always laterally inverted. This means that the image is turned always on the horizontal plane. For example, you notice that when you show your left hand in front of a plane mirror, it gives you the right. If you write something like this, the E, this is what we are going to see in the mirror, which means that the image is laterally inverted. So this is for the images formed by the plane mirror. They have their specific properties. Then the convex mirror. This mirror is also known as the driving or the driver's mirror, the side mirror of vehicles. You'll notice this is the type of mirror they use. So this convex mirror will also have specific properties. Number one is that the image is also virtual because when you look into this mirror, you are going to see yourself. So the image is virtual. Number two is that the image is also upright. is not inverted. Number 3 is that the image is always diminished. Image being diminished in the sense that the image is always smaller than the object. And number 4 is that the image is always farther than the object from the mirror. The distance of the image is farther than the object from the mirror. This is why you will see where it is written in the side mirrors of vehicles that objects in the mirror are closer than they appear. That is, the car you are seeing behind you is closer than it appears in your mirror. So these are the properties of images formed by a convex mirror. But to discuss the images formed by a concave mirror, you can't say that the image is real or the image is virtual. You can't say that the image is inverted or the image is upright. You can't say that the image is magnified or diminished or the same size. The reason is because this type of mirror, concave mirror or the converging mirror, where the surface of the mirror will curve inward, this type of mirror can produce a real image. This type of mirror can produce a virtual image. This type of mirror can produce an image that is upright. It can also produce an image that is inverted. So the type of image produced by this mirror depends on the distance of the object from the mirror. It depends on the distance of the object from the mirror. So before we look at the properties, we are going to be considering the distance of the object from the mirror. So before we look at these properties, I would like us to look at the parts of a curved mirror. So if you are to draw, this is the symbol for a plane mirror. And this is a symbol for a concave mirror. The plane mirror, this is the mirror, the front of the mirror, and the shaded part is the back of the mirror. This is the front of the mirror, will curve inward, and the shaded part is the back of the mirror. It's the same as this. You see that the shaded part is outside, and then the front of the mirror, the unshaded part, curved inward. So this is still concave mirror. And this you see that the unshaded part, that is the front of the mirror, curved outward. I can still draw it this way, but you notice that here will be the shaded, and the unshaded part will curve outward. So this is what we call the convex mirror. Okay, so we are going to be looking at the parts of the concave and the convex mirror. So if this is to be a concave mirror, okay, if this to be a concave mirror, this part here, which I call P, will represent the pole. The pole. And what is the pole? The pole simply represents the center of what? Of the concave mirror. is the center of the mirror, of the curved mirror. Remember, we are discussing curved mirror general. Both this and this will have this property. So the pole is just like the center of the mirror. The mirror, you see that the outer part of the mirror is circular, but the inner part here is kind of spherical. Like this, like half of it, and you can get the remaining half to complete. Okay? So this is the pole. So the pole represents the center of the mirror. The next part we are going to be looking at is the part we call the center of curvature. The center of curvature, if I'm to complete this now, you notice that the center of the mirror, which let's say somewhere here, the center of curvature. Now, when you look at this, the center of the curved part of this mirror is what we call the center of what? The curvature. The center of this curved sphere is what we call the center of curvature. So this is the center of curvature, which is the center of the curved part of the mirror surface. That's the center of curvature. So let me use C. All right. Now, the next is a line that joins this pole to the center of the curvature and beyond. Any imaginary line that joins the pole and the center of curvature, we call this line the principal axis. The principal axis. So the principal axis is an imaginary line that joins the pole and the center of curvature. So this line is called principal axis. The center here is called the pole. The center of the curved part of the mirror is called the center of curvature. Now the next is the point we call the principal focus. Let me use big F to present this. The principal focus. The principal focus is just like a point in between the pole and the center of curvature. So let me call here the principal focus. Now the principal focus of a curved mirror represents a point on the principal axis where rays that are parallel, any ray that is parallel to this principal axis, will have to pass through when reflected. Remember that any ray, if ray of light will hit a mirror, what will happen is reflection. So if any ray of light is parallel to this principal axis, when the light is reflecting, it must pass through the principal focus. So it is a point on the principal axis where rays parallel and closer to the principal axis will converge or appear to diverge after reflection. The point on the principal axis where rays, this ray that is parallel now, this one also parallel, you notice that when it hits the mirror, it's going to converge, because that's why we call this converging mirror. And we call this one here the diverging mirror. See, any ray that hits this is going to diverge. Any ray that hits this is going to diverge, but will appear to have converged from here. This is what happens. So if this will be the incident rays coming from the source, and these rays are parallel to this principal axis, when they hit, this is a convex mirror. When they hit the mirror, they will diverge. They will diverge, move away. Instead of converging, they will scatter, like not scattering, but move away. Instead of them coming together, they move away. So this is what happens for the convex mirror when they are reflecting. They move away, but for concave mirrors, they converge, they move together. All right? So these are the reflected rays, and these are the incident rays. So these incident rays, they diverge, but when you trace them backward, it appears as if they diverged from here. So this point here is what we call the principal focus of a diverging mirror. Why this point here, where you have these incident rays coming here when they hit the mirror, and when they are reflecting, they have to converge. They have to converge here. So this point of convergence is called the principal focus of a converging mirror, or the principal focus of a concave mirror. So when you are asked to define the principal focus, it's either they ask you to define the principal focus of a converging mirror, or to define the principal focus of a diverging mirror, or to define the principal focus of a curved mirror. So when you are asked to define the principal focus of a converging mirror, you say that the principal focus of a converging mirror is a point on the principal axis where rays parallel to the principal axis will converge after reflection. If you are asked to define the principal focus of a diverging mirror, you will say that this is a point on the principal axis where rays parallel to the principal axis appear to diverge after reflection. They appear to have diverged from this principal focus after reflection. But when you are asked to define principal focus of a curved mirror general, that means you are going to combine these two definitions by saying that the principal focus of a curved mirror is a point on the principal axis where rays parallel to the principal axis will converge or appear to diverge after reflection. Get it? All right. So thank you very much. See you on the next episode when we look at the ray diagrams for the images formed by a concave mirror. Bye.